I think for this part, the first thing that you want to pay attention is to identify the indeterminate form. This should be recognized as indeterminate form. 0 raised to power 0, it's not necessarily always 0, okay? Because, any power like 5 to power 0 is going to be 1, right? And then 0.5 raised to power 0 is 1. So this is not necessarily 0. So first of all, don't have that mindset. So you should not have that mindset. However, if you think about say 0.0001 raised to some power, say 0.1, and this guy is very close to 0 in this case, very close to 0. So really depends on like where the power or the base approaching 0, which one is faster, therefore your answer can be different. So that's why this is called indeterminate form. Similarly, like this 1 to the infinity, why this is indeterminate form, just think about this. Suppose your base is approaching 1, and then the power is approaching infinity, say 1,000, right? Huge number. And if this guy if the power, and by the way, this will be huge because 1.5 to the 10,000 is you can do the math, should be getting larger and larger if the power dominates the growth. Now, on the other hand, if you think about 1.0001 raised to some power, say 10, this should be very close to 1. So it really depends on which one is approaching, say, if the base is approaching 1 faster than the power approaching infinity, then this guy should be approaching, getting closer to 1. On the other hand, if the power grows much faster than the base, which is approaching 1, then this guy actually will be huge. Really, this depends on which one grows faster. So similarly, for the very last one, infinity raised to power 0, the same argument, okay? Now, you do want to note that these are the indeterminate form. Some forms are not indeterminate. For instance, you don't see 0 raised to infinity power, right? I know this for sure is going to be 0 because if the base is approaching 0, say, just imagine, say 0.1, right? 0.01, and the power is approaching infinity, which means, say, 10,000. I'm going to just say 10,000. So you already see that there were a lot of like 20,000 zeros already in this case, right? So so it's already approaching 0. I know this is for sure to be approaching 0, so therefore this is not indeterminate form. Another example is like 0 raised to power 1. This is not, and then 1 raised to power 0. This is for sure approaching 0, right? So just want to make sure that don't have the mindset that any combination will give you indeterminate form. Only these three, no more. So please be very mindful when you do problem. Anyway, let's now take a look at the 2 examples. So the suggestion, if you look at the notes here, the suggestion is there are 2-step processes. This is a 2-step process. First step is to, well, I don't think that my notes shows correctly. So first step, you want to evaluate the limit x approaches a, g of x times natural log of f of x. And then second step, you're going to evaluate e to this, call this as L. So your answer will be e to the L. Now, I usually don't like to break that into 2 steps, even though the book suggests that. I oftentimes, in my experience, when you break that into 2 steps, from my former students' results, I see that students tend to forget the second step. So therefore, my suggestion is combine them into 1 step. So this is the idea. First of all, you rewrite this function, right? You rewrite this function using base e. That's what you have. We have done this a lot. So we change the base, change to base e. And then move the limit to the power. So, and then you're going to evaluate this limit. So the book suggests, hey, do this as your first step, and then e to the whatever this result is, call it L. This will be your final answer. So I'm going to combine both into one single step. This is what I would do for the first problem. First of all, I'm going to rewrite this using the base e. So it's going to be e to the, if you can recall, actually e to the natural log x raised to power 2x right here, right? 2x. So 2x right here. But this 2x can be moved to the front. So therefore, I actually move that to the front. So it's going to be 2x times natural log of x. That's where it comes from. And then after that, you're going to move these limits to the, you can move limits to anywhere you like. So move this limit, x approaches 0 from the left to here. By the way, the 2 is constant, so a 2 can be moved out, okay? So that you just need to worry about the inside. So x times natural log of x. Now I would advise you to look at the problem, the notes problem, problem number 2, part B. We actually did this identical problem, and this limit from the notes problem number 2B, this limit is actually equal to 0. Basically, this x approaching 0 faster than dominates the change. And even though natural log of x is approaching negative infinity, but x approaching 0 faster than that. But anyway, please refer back to number 2b for the detail why this is 0. And therefore, this is e to the power 0. It gives you 1.